Assalamu alaikum, dear students. Welcome back, and Eid Mubarak to all of you and to your family also. Uh, Today, we are going to start a very new chapter, fresh chapter, that is friction. We have completed our first chapter, that was force and pressure. And regarding the exercises, I will upload a PDF in Google Classroom, and in the PDF I will give the answers to these those questions which are in your textbook. Today we are going to start friction. As you might remember that we have talked about a little bit about friction in the first chapter, where we studied that there are basically two kinds of force. So one is contact force and another one is non-contact force. And in contact force, we studied friction also. We say that the contact force are those which, when the two objects are in contact, between contact, that means the force exerting between these two objects or those two objects which are in contact are called is called contact force. Friction is also a contact force. Friction is a force, okay, which is opposing the relative motion of the body. If the body is moving along in suppose in one direction with respect to suppose ground, if the ball is moving in one direction with respect to ground, and the ground will oppose the direction of the motion. This means that the force will exert which will oppose the motion of the ball, and that force will drag that ball backwards. This means that the force will be exerted which pulls the that ball backwards. That's called frictional force. That is frictional force. And you might have experienced it in your day-to-day life that uh, when you get on something which is very slippery, when you walk on a slippery road or a slippery surface, what you get is you will be slipped there, okay. Or for example, if you kick a ball uh, on a slippery surface, and the ball will cover a long distance in that slippery surface, and at the same time, if you kick a ball or if we hit a ball on a rough surface, for example sand, or for example the floor which has got rough surface, there the ball will not cover the long distance as it covers in the smooth surface. What causes this force? Let me demonstrate here. Firstly, here as you can see here, uh, as you push these books, the book will eventually stop, okay. If you push this book like this, the book will stop. Even if you push it hard, it will stop also. And if you push it from this side, okay, and if you push it hard, it may cover a long distance, but eventually it will get stopped. Here is the second demonstration. um, this is the first demonstration, and this one is second demonstration, okay. This is A, and this is B here. Let me move forward. This means that this is a kind of force which is acting opposite to the direction of motion. For example, here are the books, and you apply the force. If you look at a part, if we apply the force in one direction, a force will be exerted which is between these two surfaces when they are in contact. Okay, the book and the floor is in contact. This means that the floor will exert a force. Okay, the floor will exert a force on this book, and that force will oppose the direction of motion. Okay, that force will oppose the motion. That means if the force is opposing the motion, it will eventually get into rest. That means it will come to rest eventually, because a force is exerted by here floor, and the book will eventually get to rest, come to rest. So here in B, you are applying the force in another direction, and the force, the book stops eventually, because there is a kind of force which is applied by floor, which is opposing the direction of this book. So we can say that this friction is a force which is acting between the two, which is acting, or which is opposing the relative motion. Okay, which is opposing the relative motion, relative motion when the two objects are in contact. Okay, so let us now see what are the factors which affect the friction. Okay, when is friction more or when is friction less? Let us see what are the factors affecting this friction. As you can see here, the activity in 12.2. In activity 12.2, what you will do is tie a string along a brick. Okay, you have to tie a string here. As you can see here, you have to tie a string here. You have to tie a string here. This means that when you tie a string by a spring balance, okay, you have to. This is a spring balance, and this spring balance is a device which measures this frictional force, which measures this force. Okay, this is a device which is called a spring balance. Here, as you can see here, this is the spring balance, and you have to tie a string to a brick with by a spring balance, as you can see here, 12.3 here. You need to apply some force. Okay, you have to apply here some force. You will pull it. You will pull it towards yourself, and reading on the spring balance. Note out the reading on the spring balance here. The reading will appear here as you press this string. The reading will appear here. As you can see here, there's a reading here. Okay, 0, 10, 20. This means that this is 0 Newton, this is 10 Newton, this is 20 Newton, and so on. As you pull here, the reading will appear here. Okay, the reading will appear here. When the brick just begins to move. Okay, when the brick just begins to move, the reading will appear here. It gives you a measure force of friction between the surface of the brick and the floor. Okay, and this will give the measure of the friction. This will give you the measure of the friction. This means that this will tell you how smooth or how hard is how rough is this surface. Okay, this will tell you that how smooth and how hard is this surface. If the force here is if the reading here is greater, this means that here this floor applies have greater friction. Okay, have greater friction. If the reading here is less, this means that this floor has less friction. What you have to do then now, wrap a piece of polythene around the brick and repeat the activity. You have to wrap a piece of polythene here at the brick and try to pull it again. Then, do you observe any difference in the reading of a spring balance in the above two cases? You might be, what might be the reason? Yes, you will note here the difference in the reading. Okay, firstly, the reading shall be more. Okay, the reading will be more, and second, when you wrap a polythene to this brick, the reading will be less. So the question here is, what might be the reason? What is the reason? Why is in the first case reading more and in second case reading less? This is the spring balance. Okay, this is spring balance. So what might be the reason? Can you give the answer? Yes, the reason is that here this floor has greater friction. This means that we have to apply the greater force to pull this brick. Okay, if this floor applies greater force, opposing force, so we have to apply the greater force by which we can move this brick towards ourselves. Okay, and that greater force means that the rating will be greater here. And when we wrap a polythene here, this means that our surface becomes now a smooth one. Okay, surface becomes now smooth, and when the surface becomes smooth, it will have less friction, and when the friction is less, this means that we have to apply less force to move this to move